Going. Okay, so the recording is started. So, good morning, everybody, and welcome to the second day of our Reproducible Computational Environments Using Containers course. Yesterday, we looked at Docker. I hope you found that interesting and that you enjoyed going through the process of learning how to use Docker and build containers. Today, we are going to use or look at Singularity, which is another container platform. We're going to be using it on both on a sort of HPC platform that you've been provided access to, which in this case is ARCHER2, and also when we come later on to building images, we'll be using Docker, so you'll be able to actually use your Docker knowledge from yesterday and apply that to building Singularity containers. So for this morning's session, we will be working mostly on Archer. So I hope that you have been able to follow the setup instructions and get yourself set up with an ARCHER2 account and be able to sign in. If you haven't, there will be time to go through and look at that, and the helpers are on hand to assist if you're having problems with that. So for now, if you haven't been able to sign into Archer, please do put a message in the chat. I'll put a little poll up at some point soon so that we can see how many people are kind of ready to go with Archer. But for the first part of the course, I will actually be doing this on my terminal. You'll be able to see how things work on the terminal, and we can then have a short break in a little while to make sure that people have had the ability to log into Archer and check that it's working. So just to give you a little bit of an overview of what we're going to be looking at today, we've got a set of 8 different episodes for today's session. I'm going to move to the first one, getting started. I should actually put into the chat the link, so I guess most of you got it from the email, but I will just drop that into the chat for anybody that hasn't, or that hasn't got it handy. So that's the link for today's Singularity material. So we're going to be doing this as two-hour sessions, so we'll run till about 12, then we'll have a couple of hours break and do 2 till 4. The plan is to work through up to the end of episode 6. We've actually got it's showing here that we go to the lunch break at the end of episode 7, but I think probably we'll get as far as episode 6 before the lunch break, and then we'll look at building images. Sorry, apologies, up to episode 7, and then we'll look at building images after the lunch break, so 9. So we'll get up to hopefully up to 7. Before the lunch break. I'll just move on to the getting started episode. So there are, as I say, there's 8 episodes in this material. The introductory episode, I'll give you a little bit of background, talk about Singularity and the general kind of approach that Singularity takes, and we'll look at a sort of brief comparison with what we did with Docker yesterday. Then we will look at the process of working with containers as an end user. So this set of 4 episodes will take you through the sort of general principles. It's kind of almost mirrors what we did with Docker yesterday, but shows you how this is different in the Singularity environment. And then we will look after that at actually building images and then looking at how to run those in parallel. So we're looking at running parallel jobs on an HPC platform. So lots of stuff to get through, and hopefully we'll make good progress. A few things to just note here. So this lesson is we've taught this lesson several times, but it is evolving, and it's not, I think it's fair to say, quite as mature at the moment as the Docker lesson that you saw yesterday. So we're very happy to have comments on things that can be improved or things that you'd like to see that are not in here. And also it's probably wise to take the details at the top of the timing as a rough guide rather than an absolute set of timing, because we are extending the material or changing material as we go along to improve it. So those times may not always be exactly right, but those give you at least a rough guide of what the timing should be for that episode. But we will obviously optimize those as we teach the lesson more and get a better idea of things. So we'll go through some of this background material, and then we'll have a chance to, if you've got any issues with accessing ARCHER2, to look at that. So what is Singularity? Singularity is another container platform. It's in some ways as a user very similar to Docker. So as you'll see when we start working with it, it kind of has a lot of similarities. It looks in many ways like Docker. But in other ways, particularly in the way that Singularity is built and architected, it's fundamentally different to Docker. And I think we actually spoke a little bit briefly about this yesterday. But what this means is that Singularity is very well structured for and very well suited for running on shared high-performance computing platforms, as well as on a laptop or a desktop. So what you'll tend to find is that if you are in an institution where you have access to an HPC infrastructure, maybe you have a cluster, and you have some sort of platform that you can sign in and run parallel jobs on, or you can run large-scale jobs, you will find that Docker is generally not installed on these platforms. So the main reason for that is that Docker, because Docker requires to run a daemon as the sort of root admin user, and you need to be able to have sudo access, or you need to be in the Docker group. Your user needs to be in the Docker group to be able to run many of the, or most of the Docker commands. This means that Docker presents major kind of security issues on a shared platform. So that's not to say that Docker is inherently insecure for that reason. It's just a design decision in the way Docker has been built, and it's, Docker is very widely used on many platforms. But from the point of view of shared cluster platforms, Docker is not an ideal choice for that reason. And so what Singularity does, which takes a different approach, is Singularity runs in a way that doesn't require any special administrative privileges for the user running Singularity. So once it's installed on the system, end users can interact with it. Behind the scenes, the Singularity code does do things that require some sort of administrative privileges, but it basically very briefly gets the administrative privilege that it needs to do those tasks, and then kind of drops back to the user level. But all that's hidden from the user, and it doesn't require the end user, to actually have administrative privileges on the platform. So from that point of view, that's why Singularity is often used, or increasingly used, on high-performance computing or cluster platforms. And certainly for many people, I guess, on this course, if you're working on research that involves working with data or large-scale computation, then you're quite likely at some point to come into contact with Singularity on these large cluster platforms. So what we're going to do is we're going to look at a little bit of sort of general background about Singularity itself now, and then sort of I'll show you some of the basic commands and explain to you how it works at a basic level, and then we'll take a short break to check that people have access to ARCHER2. So as it shows here, Singularity was developed within the research community, so it's come out of the kind of research space. It's an open source code. It's currently available. It's a little bit complicated because Singularity has gone through a number of kind of changes over recent years, but there are kind of two repositories for Singularity at the moment. One is this kind of open source repository on GitHub under the Next Generation of High Performance Computing organization, and that's the one that we're kind of focusing on. But there's also a sort of commercial or semi-commercial, I don't know what's the right way to describe it, but there is a company that is kind of supporting Singularity as well, and there is another GitHub repository for Singularity that they are running. So this is all kind of things that have been changing over the recent couple of years. It's not something that should be a major concern. It's just to make you aware that when you search for Singularity, particularly if you're ever looking for releases or for the code, that there are kind of different places that have Singularity, and it's called Singularity in both cases. So it can be a little bit confusing. But we're working specifically with the version that's from the next generation of high performance computing. And in fact, as we'll see in a minute, we're going to be using actually a slightly older version than the very latest, and the older versions all came through kind of the same route. So they're actually all the same version of Singularity. As you go back, it's only very recently that it's sort of split into these two camps. So there's a note here about installing on your own system. If you have a Linux system that you have administrative access on, and you want to install Singularity locally on that system, then there are some details provided in part 2 of the material. At this stage, you don't actually need to have it locally on your system because we're providing access to ARCHER2 where it's pre-installed. But when we go later on to building images, the one option will be to run on your own machine if you want to. But as I mentioned earlier, we will actually be using as the main approach to this, the Docker container for Singularity, which will allow you to test your Docker knowledge from yesterday. So this is something, the installing it on your own machine is not actually a requirement, and it's probably what I think we'd class as a kind of advanced task. We're not going to go into it in detail, but if you do want to have a go, there are instructions for doing that. If you're not running a Linux machine, then it's not an option anyway, and in those cases we'll stick with running through the Docker container, which we'll talk about later. So it does now ask for you to sign into the platform we've provided access to. If you've already got a terminal in ARCHER2, that's great. If you haven't, we'll come and look at that shortly, but I will just kind of finish off going through this introductory part anyway. So something that's highlighted here, many HPC platforms use a system called modules to provide various different versions of different pieces of software. So if you are familiar with using an HPC platform, it's possible that you've used something where when you want to use a particular application or a compiler or some tool or whatever, that you have to say module load and then the name of the tool. And what that means is they can support lots of different versions of tools, and it's often the case that you'd say module load, the name of the tool, and then some version number. So for some platforms, you may have to type module load Singularity. But in fact, on ARCHER2, Singularity is actually installed directly on the system. You don't need to load any module. It's available straight away in the path. So in fact, if you are on an ARCHER2 terminal, you should in fact be able to type Singularity -- version, and it should be there straight away. And what I'm going to do now quickly is just switch across to my terminal on ARCHER2, and I will show you that if I type just the first few letters and I press tab, it auto completes, so we know that it's found it in the path. But you can type Singularity -- version, and we will see there that it's running Singularity version 3.5.3-1, and that's the version that's installed by default on ARCHER2. So if you do have an ARCHER2 terminal, then you can give that a go, and you should be able to see that. And you may see different output. I mean, that particular version seems to be some of the versions. If you're running on your own install and you've installed 3.5.3, you might just see 3.5.3 like that, as shown in the instructions. But here we can see we've got a -1 on the end, so it's probably like a patch release of that. Okay, so I will carry on through the this information, just to give you some background here on the containers and images for Singularity, and then we will. We're just quarter past, so we'll probably break about 25 past to let you have a go at sorting stuff out on ARCHER2. So just a brief note here, and I think this was probably covered yesterday, about images and containers. So we used the terms obviously a lot yesterday, images and containers. So this is just really to clarify what we looked at yesterday. So I think Andy used yesterday the kind of cookie cutter analogy for images and containers, and sort of gave you this idea that an image is kind of like a template, and you can take multiple copies of that template as containers. So the way that that I've described it here is to say images are bundles of files which include an operating system, some software, potentially data and other application files that you may need, and they may be referred to as a disk image or a container image, and they can also be stored in different ways. So we saw yesterday how with Docker, images are kind of multiple files that you often saw when you were running Docker images, pulling down sort of sets of layers of files. But images can be represented in different ways, and they can also be represented just as a single file. And in fact, in the context of Singularity images are generally just a single file, as we'll see shortly. And the container is this kind of virtual environment that's based on an image. So to take that kind of template model, you can have one image as your sort of template, and you can spawn multiple containers based on that image template. So the container is the kind of running entity that's realized from the image. And that is the thing that you actually interact directly with when it's running, and you can run your applications in there and go in there and interact with it directly if necessary. So that's the kind of, just to sort of cement what we looked at in terms of images and containers. And as I just alluded to, we had this kind of idea of different types of images. So when we looked at Docker images, we had this concept of layers. So let me just check if we've got a question there. Switch to my other window. Sorry, 1 second. Do does somebody have a question? Thought I heard a hand up. No. Okay, I shall carry on. So if there is a question, if any of the help or spot a question, please do interrupt me and let me know if there's anything that I've missed. I'm trying to monitor the chat as well, but please do let me know if I've missed anything. So we have this concept in Docker of an image being made up of layers, and we heard yesterday about how that gives you benefits, such as you can share different layers between different images. So if you've got a kind of base, if you've got 10 different images that are all based on, for example, Ubuntu 2004, you don't really want to have 10 separate copies of Ubuntu 2004. It's very inefficient. So you can have one layer that represents that kind of base image, and then all of your other images can have the kind of the changes, the differences between the base Ubuntu 2004 and that particular image layered on top of it. And it gives you a much more efficient way of storing containers and storing data, and that's the approach that Docker takes. In Singularity, things are a little bit different. It uses its own image format called the SIF Singularity image format, and in this case, images are provided as single SIF files. So that kind of loses the benefit of the layered system in Docker, and it does mean if you've got 10 images that are all based on Ubuntu 2004, you do end up with sort of 10 copies of that in your 10 different images. But for various reasons, that approach is more practical in the context of Singularity, and particularly in the case of being able to move images onto HPC platforms and move them around. It's much nicer to be able to just move around single files. So there are pros and cons to these different approaches, but that's the approach that Singularity takes, is having this kind of single file as an image file, and that's what we'll be looking at later on when we go through the process of actually building images. So there is also, we saw yesterday Docker Hub, and you will probably registered for an account with Docker Hub yesterday. There is also a Singularity Hub, which is Singularity's own registry for container images. We will also see that Singularity can also run things from Docker Hub, so it can run Docker images. There are various reasons, again, why you might choose to use images from Docker Hub or from Singularity Hub, but that's just to point out here that there are these sort of two, and there is a sort of Singularity equivalent to Docker Hub for storing Singularity images. Let's just have a look at a very brief example. So if you are on ARCHER2, you'll be able to follow along. If you're not, don't worry, we will have time shortly to look at that. So what I'm going to do is I'm going to switch across to my, just take a copy of that to save me having to type it, but we'll just switch across to the ARCHER2 terminal. So on my ARCHER2 terminal, I'm going to make a directory called test, because we've got somewhere to put the file, and I'm going to change into the test directory. And I'm going to do something which we'll probably find looks very similar to what we did in Docker. I'm going to do Singularity Pull. What I'm going to do now is give it the name of the file that I want to store this image to. So I'm telling Singularity I want to pull an image, and I want to store it to a file, and I'm going to call that file helloworld.sif, SIF, because it's a Singularity image file format image. And then I tell it the path to the image that I want to download. So in this case, shub : is what tells us it's coming from Singularity Hub. This is the user who has published that image, and this is the name of the image. So that's kind of the path to the image file. So if we press enter, right, so something interesting happened there, and that was actually partly my fault, but that's telling me that it's got used the image from a cache. We'll come back and look at that in a moment. But what you will see on your system is likely that if you manage to run this successfully, you'll see some output that looks a little bit like this. And what it will actually tell you is downloading the shub image, so it's pulling it from the Singularity Hub, and you'll then see it pulling some data. That's probably the image size. I don't think has changed since that was there. So you'll see something like that, and you'll see the image downloading. And what is actually happening there? So Singularity has gone off to the Singularity Hub registry. So this is a service running on the internet. and it has looked up that particular image that you've told it to look for. It's found it, it's pulled down the data, and it's stored it locally into a file hello-world.sif. And if I look in my directory there, test that I created, so that file wasn't there before because I just created the directory here and then changed into it, we now have a file hello-world.sif. If I look at the size of that file, so if I do an ls-l, we can see it's around about 60 megabytes. So that's that will be the size we saw there, 59.75. And that image is now there on this system and available for me to use. So what can I do with that image now that I have it there? Well, obviously, be useful to be able to run it. So what we want to do is to run a container that's based on that image. And to do that, we can use the Singularity Run command. So if I type Singularity Run and I tell it the name of the image that I want to run a container from, and I hit enter, I see a warning about bind mounts. Don't worry about that. Now that's specific to this particular platform. But then I see the output that's come from that, which is printed here. And that's what we expected. So that means that the container has run. So we created a container. So Singularity created a container from that image, and it ran it. And we did all that as our own user. So if I type who am I to see my user, I'm not root, I'm my own user. I don't have any special privileges on this platform. It's a large-scale HPC platform with lots and lots of users, and I am not a privileged user in any way at all. So I have just a standard sort of set of user privileges, but I was still able to pull and run that image. And if that was Docker that I was running with, I would not be able to do that. I would need to have some sort of ability to run either with sudo, or I'd need my user to have been given special privileges to be in the Docker container. So this is showing you already the kind of the benefit of Singularity is that you can work completely in user space on an HPC platform, and you can run images. So just to finish off this section, so we've got to this point where we've been able to run a container based on this image. And when we ran it, we saw this output, but we didn't actually tell the container to do anything. We just said run. So we said Singularity run, and we said run a container based on that image. So how did it actually know what to do? How did it decide what it was going to do when we ran it? And the way that this works in Singularity is that within an image, there is some kind of image metadata that tells the image what to do by default, what to run by default. So in Docker, we saw that there was this idea of kind of the entry point or the CMD command that you put in your Docker file to tell it what to run. This is kind of similar to that. And that basically is some metadata that's embedded in the image that says when you run a container from this image, this is what you actually run by default if you're not told to do anything else. And we can have a look at what that command is using the Singularity inspect command. So if we type Singularity inspect and then we pass it the image that we're interested in, so if I type Singularity inspect -r and then I pass it the name of the hello world.sif image and I run that, it shows me a script, and that script is the script embedded as the kind of run script. So -r here is telling you want to see the run command or the run script for this image, and what this is showing you is a very simple shell script that's been embedded in the image telling it what to run. So within the image it says run bin bash, so a bash shell, and use that to execute this shell script that's in the / directory within the container, within the image, sorry. So when the container is created from the image, it runs this command, and that's what printed out this message that we saw here. Okay, so that's how we know what the what a container based on an image is going to run by default. But there are of course ways to run other things that we'll look at as we go forward. So with that, I will wrap up this particular introductory episode, and we will have a little bit of time to sort out any login issues and to give you the opportunity to just have a go at pulling an image and being able to run it. one thing to note is that, and I don't know if this will be a problem or not, but there are, or there have been previously, some download limits on the Singularity Hub. So you may find, if several of you are trying to pull that image, that eventually you start getting an error 403 forbidden error that says you're no longer allowed to pull the image. If that happens, we've got a local copy that you can use. But if you do get that, it's not something that you're doing wrong. It's probably just that the Singularity Hub has reached a sort of limit of the number of container pulls that it can handle. I'm not sure if that's still a problem. It may be that it's not anymore. But just to flag that. So we will take a pause there. So it's what's just come out to 1/2 past. I think we'll give ourselves till 10:40, so just over 10 minutes, to give you an opportunity to solve any issues. We've got the helpers available here, so they will do their best to assist you. I'm happy to answer questions. I will, I think, probably stick here in the main room, but if you want to go into a breakout room, the helpers will assist with that, or let me know and I can move you to a breakout room. Andy, did you want to say anything about, or did you want to do any sort of quick run through of an example for anybody who's stuck with how to go, how to get things working in Archer? Or I think, in fact, Andy might be in a breakout room, so I'm not sure. Okay, so I will do a quick run through for anybody who is struggling with things here. So just a few pointers to point out here. So I'll go to a terminal on my machine. In fact, I've got a Linux machine here that I can use as an example. So one of the things that I think has been causing some problems is to do with keys for accessing ARCHER2. So the way that things are set up is that you need to have your account created in Safe, and when you do that, you need to provide a public key. So to access ARCHER2, there's a form of kind of two-factor authentication. So you need your password that you've decided, or in fact, I think initially you're given in Safe a kind of default, an auto-generated password, and you're then asked to change it the first time you log in. So there's a password anyway that you need to type, and then there's also a public-private key pair. So if you've not ever used any system where you've done key-based login, what that means is you have a public and a private key. The private key is a file that remains secure on your computer, and you should make sure that there's no way that anybody can access that. And then the public key is what you give to ARCHER2 by adding it into the Safe system when it asks you to add a public key. And that is then used on the ARCHER2 side to kind of verify traffic that's coming from you and to ensure that it's definitely from you and that it's encrypted using that the relevant credentials and so on. So to create a public key, a public-private key pair, sorry, you use the Ssh Keygen command. So I'm just going to type that in here so you can see. So Ssh Keygen. So I can see Andy's just joined us back actually. So Andy, I'm just doing a quick run through for anybody that's got issues with key generation or anything. But in a minute, if there's anything you want to run through in terms of ARCHER2, please do let me know.
No, that's perfect. If there's anybody else in the chat who wants to go to a breakout room, I'm available now to go out and look at something if people want to do that.
Right. Okay. So just to go through, so to create an SSH key pair, so you say SSH Keygen -t, the type of key that you're creating, and it's an RSA type key, so we say -t RSA, and then the size of the key. So this is the number of bits of the key, and of course, the larger the number of bits, in theory, the more secure it is, the more difficult it will be for somebody to break that key. So we use, I believe, 2048 bits for this. I think different sizes of key are accepted, but that's the kind of recommended size here. And we press enter, and it then says it's generating a public-private key pair. It asks, where do I want to save the file? This is a kind of default file name that's used, but if you already got a key pair that's set up with the default file name, I certainly advise not using that file name because it will overwrite it. So I'm going to actually just do it as a demonstration. I'm going to put it in the directory that I'm in now, and I'm going to call it ID ARCHER2, and I press enter. I have to put in a passphrase. So I pick a password, it asks me to repeat it, and it then tells me that it's generated the key. And if I now look at the local directory, I can see there's 2 files there that have been generated. This one is my private key. That's the one I have to make sure is super secure on my system and not accessible to anybody other than me. And this one is the public key, which is the one that I can share. So I look at my public key by just using the cat command. What you see there is the public key that's been generated. And that's the thing that you either paste into the safe user interface, safe web interface when you're asked to provide the public key, or you can upload the file directly. But you can just copy and paste that and paste it into the box that's provided. So that's what it's asking you to do for the key generation part. And once you've done that, I believe that's the kind of the main bit. Everything else should be pretty self-explanatory within the web interface. And then you can submit your account request, and that will get approved. And then you can actually go and sign in. So to sign in, you have to tell SSH which key to use. So in this case, if I was to go, so I haven't actually, I've just generated that key there. Obviously, it's not registered with ARCHER2 because I've only just created it. But just to show you the sort of command line that you'd be using to access ARCHER2. So so use the SSH command, you say -i and the name of the key that you are going to use, the name of the private key that you're using to make that connection. So in this case, it was the file that I've just generated as for an example. So the ID ARCHER2, so use the -i switch to provide the key. And then you have to say your username on the remote platform. So you'll have been asked to select a username. So let's put in username @ and then it's login.archer2.ac.uk. So that's the command that you're using to actually connect to ARCHER2. And the first time that you connect, it will ask you for a password. And the password it's asking you for is the one that you get from the safe interface. So it's the auto-generated password that was provided by default at the start in the safe interface. So you'll type that in, and it will then, I believe, ask you straight away to change that password. And I think it then comes up with a message saying something about enter LDAP password. Andy can probably confirm if he's still here. But I think basically
it's just I just put it in the chat. It's like two messages.
Oh, fine, okay,
message
right.
up in the chat. It says you're required to change your LDAP password immediately. Enter login LDAP password. You enter your safe, the password you got from the safe again, and then it will say enter new password, and it'll ask you to confirm that twice, and then your password's changed, and you're away from the one from the safe.
Right. Okay. Okay. So go through that password change step first, and then once everything is working, you'll find that every time you do this login command, it will ask you first for the password. So that will be the password that you changed, the new password that you selected yourself. And then if that password is successfully verified, it will then ask you for your key password. So that's your kind of two-factor authentication. It's asking you for those two different security credentials. So that's basically the process that you have to go through to sign in. So there's a really interesting question there that's asking about this is making the point. This is very similar to what we saw yesterday, and what is the benefit of learning Docker? So as we'll see in a little while, Singularity only works at the moment on Linux platforms. Docker obviously is much more flexible, works on a wide range of different platforms. And Docker kind of really has, I suppose, a different sort of usage model. So with Docker, there's a huge ecosystem of other kind of tools that can be used. So Docker is very frequently used for deploying large kind of maybe web infrastructures and things like this. So if you want to deploy a web server and a database server for your web application and various services and whatever, Docker has an ecosystem of tooling, things like Docker Compose that we didn't look at yesterday, Kubernetes, and these other tools that can allow you to kind of orchestrate containers. So container orchestration is a big thing when you've got large applications. and Docker is very well supported for that kind of environment. And Singularity doesn't at the moment have that kind of infrastructure. It's very much a different sort of use case, I guess. So the two are useful in different environments. Particularly, I think the benefit of working with Docker. Obviously, we looked at the fact that having the root access in Docker and the Docker daemon, whatever, can be a problem. And in the case of shared HPC platforms, it is indeed a problem. But actually, it's often very useful. So if you want to be able to create containers from images, and then you want to be able to edit the files, and you want to be able to change things, and then kind of commit your changes back and whatever, that's much more straightforward in Docker, and that requires this kind of administrative access that you get. So yeah, I think it's very much the case that there are different use cases, but it's very nice that there's a lot of similarity between the two. And it's definitely the case that that there are cases where one or the other is better, and the similarity in the commands makes it very easy to switch between them and offers you a lot of benefits. Okay, so we've got, I think most people now are okay. Hopefully the helpers are assisting anybody who is still having problems. And I think what I'm going to do is move on, because I'm very conscious of time, and I can see that 95% of people seem to be okay, and I think, as I say, everybody else is being assisted. So if anybody else is still having issues, we will take a break in probably about 20 minutes or so. So there'll be another opportunity to look at anything there that's causing a problem. But I will now move on to look at the next episode. So this episode looks at the Singularity Cache. So what I'm actually going to do, I'm just going to stop the poll. Sorry, let me just close that. Okay, so we saw how to get an image. Let me just switch my terminal back to the Archer terminal, so we're ready for the next section. So we saw how you can pull images, and in this case we looked at how to pull an image from the Singularity Hub. So what happens when you pull an image? Where does it go? And what is this idea of a thing called a cache? And in fact, you saw when I ran my image pull, or you may have noticed when I pulled my image before, that actually it said it had come from the cache, and I didn't go into detail because I knew we were coming to this episode next, but I will now explain to you a little bit more about how that works. So when you pull an image from the Singularity Hub, you're going off to a remote registry and you're pulling data from it. Now, in the case of the image that we pulled, it's pretty small, it's 60 megabytes, it's really not a major issue. But of course, if you're working with big scientific applications and you've got large images and you have to pull them from a registry, every time you pull that image, you might be pulling gigabytes of data. And of course, it's very inefficient. It's unnecessarily using bandwidth. If you have to do it lots of times, it's much easier to do it once and store a local copy. And it's time consuming, and it's potentially error prone if you get errors in the file download or whatever. So when you pull an image be it from Singularity Hub, or as we'll look at later, potentially from Docker Hub, unlike in Docker, where when you pulled an image, it goes into this kind of local Docker registry, and you can do Docker container, Docker image ls, and you can see the images listed. In Singularity, we saw that we end up with just a file sitting on our file system. So we can see, if I run ls here, I've got that hello world.sif file, and I ran the command to pull it. So I ran my Singularity pull, and I said where to store it. Oops, not going to actually run this again. I'm just showing you the command, and then we said shub, and we said which image to pull. So we ran this command, and we ended up with this file sitting on our system. So we had the illusion that basically that file was downloaded and dropped straight here, and that nothing else had happened. But in fact, that's not entirely true, because what actually happens is Singularity has an image cache. And so if I delete the file, so I can actually demonstrate that. So there's my file, I delete it, and you can try this too. And we have a look, the file's definitely gone. And I then pull it again, and we're actually going to see exactly the same thing that I saw before, because it's already there. So it said info use image from cache, the file is back, but it never actually went off to the network and pulled the image. So the image is obviously coming from somewhere on this system, and there's a question about how it got there and where it's come from. So where it's come from is this Singularity cache. So what's actually happening is that when you pull an image, as well as being stored in the directory that you're in with the file name that you gave it, it's also at the same time being taken, a copy of it is being taken and put into this image cache that Singularity is storing locally on the system. So what it's done is it's taken a separate copy of the image such that when we delete the image and then we pull it again, it doesn't have to go off to the remote registry. It says, let me check if I've still got a local copy in the cache. If it has got a local copy in the cache, it just takes the copy from there and copies the file back into the directory that we're in. So it saves that process of having to go to the network again. So how can we actually see what's in that cache? Well, we can use the command Singularity cache list. So I guess you could think about this in the content. The similarity with Docker is the Docker image list, or Docker image ls. So if we run that, it tells us that we have this cache and that there's one container file in it. It's using 62.65 megabytes, which is the size of the hello world image that we've got here. And that's all very well, but we can't actually see what's in there. We can just see that there is something in there that takes up that much space. So if we want to see a little bit more detail, we can use the verbose flag -v to Singularity cache list, and that should tell us a little bit more about what's actually there. So we run that again with -v. Now we see a little bit more information. We can see that the name, the date that it was created, and the type of image that it is. So here we can see that it's hello world latest. What it's actually done there is it's put _latest onto the file name, because that's effectively like the tag for the latest version of the image. It's a sort of default tag because we didn't specify any other tag. And we see that it's a type of image shub, which means it's come from Singularity Hub. And then we see the same as we saw before with the sort of summary of how much space is being consumed. Okay, so we know that we've got this cache with the image in it. What if we want to remove stuff from the cache? Because perhaps we don't want it to be taking up lots of space. So maybe we've pulled 20 different images. Our cache might be taking up many gigabytes of space, and we've now finished with what we're doing, and we don't want all that space to be consumed on our system, and we want to remove those images because we know we don't need them there anymore. We can then use Singularity Cache Clean to clean the cache. So if I then run that, so this tells me it's going to delete everything in the cache. It's going to delete all the containers, and it does tell me that I could have done the dry run option to see what would be deleted before actually doing it. In this case, I know there's only one image there, and I'm happy to delete that. The default is no, so that we don't accidentally go and delete everything without meaning to. But I'm going to press yes, and it now tells me that it's removed a bunch of stuff, a bunch of data. And the interesting thing there is you can actually see the paths of the data that's removed, and that shows you where it's storing the cache. So in fact, what it's done is it's created a .singularity directory. So if you're not familiar with Linux, directories that are prefixed with a dot, or files or directories that are prefixed with a dot, are kind of hidden files. So if you do an ordinary ls, you won't see them. But if you do ls-a, that shows you all files. That will include the dot file. So it's created this kind of hidden directory in my home directory, and it's using that as the place to store all of the files. And these different directories that are listed, library, OCI, temp, shub, etc., are different types of image. So in fact, we know that ours was an shub image. So the only folder, the only directory in this cache that would have had anything in it is going to be the shub one. But the others are all sort of created there, and it just deletes everything out. So what it's doing is just wiping out all of the contents of the cache. And I can verify that if I look at the .singularity directory in my home directory, I can see that there is a cache directory in there, and there's now nothing in it. So it's been completely empty. So okay, so now if I now pull the image again, so let's just go back to through my history and Singularity pull that image again. oh, I've already got the file in my, so in fact that's very interesting. What that's showing you is that it won't overwrite the file if it's already there. So so let's just keep it as a backup, but we'll just move it to, so I'm just renaming the file so I haven't got, so now there is now no longer a file called hello-world.sif, there's just hello-world.sif.old, which we've just kept there as a backup. We now try and pull again, and what we see is the image being pulled again. So this time it didn't say retrieving it from the cache, it actually had to go and download it again because it wasn't in the cache. So if I now do my Singularity cache list -v, we see that it's back. And in fact, it was created just now at 10:53, so that's the version that we just downloaded. And we can also show that that file is actually in the cache by looking in the .singularity cache directory. Now we see it's created a whole bunch of directories in there. Those are the ones that got removed before. And if we look in Shub, because it's an Shub image, we see there is some not very user-friendly name file in there. If I just do a full thing, we can see that that's a directory. So let's look in that directory. And there is our hello world.latest.sif. So that's where the file is in the cache. You don't really need to worry too much about that. You just know that it's there, and you can use the Singularity cache list command to interact with the cache. But you do know then you've got a copy of it there, and you can see where Singularity has put it when it's pulled the image. So hopefully that makes some sense. Does anybody have any questions on the cache element before I move on? Let's just check in the chat here. Right, so there's a very interesting question there about if you are on a system where you can't make outbound connections. So in other words, you can't pull things from Singularity Hub. So yes, you can work purely with the SIF files and you can copy them. They won't, in that case, go into the cache, I don't believe, when you run them. I think it's purely just being used as a local file. So the cache only applies when you're pulling the files from some remote location. But if you copy the SIF files from elsewhere, then you won't have any other problems. You can use them as you would with any SIF file sitting in your directory that you've pulled from somewhere else. Yes, it's certainly okay to take copies of the files. I mean, that's one of the benefits of and that's probably, I guess, probably one of the reasons for the design decision to have single image files is that you know, it's much easier to work with moving them around. When you've got all these different layers, as you have with the Docker images, they're not really very well structured for sort of manually moving them around. They really work much better if you use all of the Docker tooling and the sort of ecosystem of Docker tools to work with them. But yes, certainly you can just copy the files around and use them on different systems. Is there any other questions there that I've missed? Apologies to anybody if I've missed any questions. Let me just have a look. There's quite a lot of activity there. So there's a question whether there's a specific container tag syntax like in Docker. So as far as I'm aware, I don't believe that there is. There might be in the context of Singularity Hub, but in the context just of the purely SIF files, you can just call the file whatever you want. Let me actually go and have a look at that. In fact, I'll come back to that after we're going to take a short break shortly. I'll come back and answer that, but I don't believe that. I think maybe with Singularity Hub there is a way of versioning the images, but certainly just for local SIF files, there's no kind of requirement to follow any structure like that. You can just call the file whatever you want. So that's a good question, and I will come back and address that shortly. Any other questions I've missed? Don't think so. I think everything else has been answered. Okay, so where are we up to? We've just finished the Singularity cache. So there's actually, we have a break here now. After the break, we're looking at using Singularity containers to run commands. I think most people are back. So let's carry on in view of time. I think we're very keen that we get through these first few episodes in this part of the session. So, okay, so I'll end the poll there and we will carry on. So we've seen how to do a very basic pulling of a container, pulling of an image, sorry, and running a container from that. And we've seen how we can see what gets run by default. We looked at using the inspect -r command to see what gets run within the container that you generate from an image by default. So now we're going to look at how do we run some different commands within the container, and how do we access a shell within the container. So if we want to actually do something different to what the kind of default configuration of the container, the default configuration is when we start the container, or perhaps we have an image that's configured by default just to run a shell, and we want to run stuff in there. So that's what we're going to look at in this episode. So running specific commands within a container. As I mentioned, we saw that we could use Singularity inspect, and we can see what gets run by default. But if we know the path of an executable that's within the container, so we have this image, it's got a whole bunch of files in it, and if we know, perhaps because we created it or because there's some documentation that's provided with the image that tells us within the image what the kind of file structure is, that there's some particular file that we want to run, we can use Singularity exec to do that. So if we take the hello world image as an example, we've got our hello world.sif file sitting there, and in this case we're going to use the command bin echo. It's a pretty standard Linux or Unix system command, so we can assume that it's there, and we're going to just run echo and then pass it some parameters. And for those of you not familiar with echo, what it basically does is just prints the parameters that you provide to the screen. So it will just echo the text to the screen. So let's give that a go. So if we go to the terminal, we can double check that we've got our hello world.sif there. I'm going to get rid of the old one, we don't need that anymore, so just to avoid any confusion. So we'll take away the hello world.sif.old. So there's our hello world.sif image, and we're going to say Singularity exec. We're going to tell it the image that we want to use to create a container from, and we are going to tell it what we want it to do. So we want it to execute the command bin echo, and we are passing the parameters hello world. Now I suspect if we use the exclamation mark actually on here, that might cause a problem because we're in a bash shell. It's going to interpret it. Let's try it and see. I suspect it's going to interpret it as a shell command, and it's going to get upset. In fact, it didn't. Okay, it worked. So I guess the command correctly handles that. So yeah, so there we go. We ran we ran a container based on this image. If we'd done Singularity Run and we hadn't provided any other parameters, we would have got the standard output that we saw before that runs by default. But instead, by using exec, we've told it to do something different. So we've said create a container from this image and run the command bin echo hello world. We get our standard warning that we always see on this platform, and then we see the result of the echo command hello world. So we've been able to run a command. So that what we can see there is we basically overrun the default run script. So if you remember from before, the Singularity inspect -r and that image that we just used, there is some default run script in there. It will call that if we say Singularity run and don't provide anything else. It's called the run script. If we want to override that, we use, as we did before, Singularity exec, and put in whatever we want to put in there, and it runs that command that we've given it with those parameters. Okay, so hopefully you've been able to follow along with that. So we'll try a quick exercise now. So if you're familiar with any Linux commands, then this will probably be very straightforward. If you're not, you may want to have a quick look around to see what seems to be the right command. But the exercise here says, can you run a container based on the hello world sif image that prints the current date and time? So have a go, see if you can work out how to do that. As I say, it's a very standard Linux command that does that. If you're familiar with it, it will probably take you all of 5 seconds. But if not, do have a search around, see if you can find the right command. I'll give you a couple of minutes to do that, and then we'll look at the answer. And in the meantime, if we have any questions, let me just see if there's anything there. So. Okay, so there's actually a really interesting question here. So when using bin bash, I still see my computer. What kind of environment is Singularity mounting? So I guess what you're referring to there is if you open a shell. So if you run bin bash, you still see what looks like your home directory or whatever in the container that's generated. I guess that's probably what you mean. So we're actually going to look at that in a little more detail in a minute. So I won't go into detail of answering that now because I think it's in the next episode that we're just about to come on to. But yes, that's a really good point, and that's something that's it's a good spot that is actually the case, and definitely, as you probably see, that's rather different to what we saw with Docker, and that's one of the kind of differences, and we will address that shortly. Any other outstanding questions? Don't. That to work. That's great. If you haven't, then it may well be because if you're not familiar with Linux. I quite understand. It's something that you may not be aware of the command that's required. In fact, the command we're getting at here is bin date, and you can see that if we run that, so if I switch back to my terminal and I say Singularity exec, so create me a container from the hello world.sif image and run the command bin date, and there we go. We see the date and time printed. So very straightforward, but nice example nonetheless that you can run whatever commands for things that are embedded within the image, or for executables or programs that are embedded within the image, and it will run those for you and print the output. Okay, so at that point, so we'll just have a quick look at the difference between run and exec. I think I've pretty much covered this just before, but just to clarify that, so when we ran Singularity exec, we saw that we provide it with executable. It points to the executable inside the image. So when we run the container based on that image, it says run me this particular command. Whereas when we use Singularity Run, it was running the default command, and we saw that we could use Singularity inspect -r to see what that default command is. Hopefully that's clear. So let's move on now to look at how we run an interactive shell. So far we've seen a case where we run commands that are inside the Singularity image, or we run the commands in the container that's created from the image, and then the container just dies straight away. So we kind of bring up the container, we run something from inside the container environment, we get the output from it, and then the container exits. That's great if you've got a command in there that you want to run, but what if you want to actually do something in the container environment and you want a bit more flexibility, you want to have a look inside, see what files are there, so on. Then you might want to run a shell within the container. So let's have a look at how to do that. I'm just checking if we've got any. So there's there's a point there about whether you need to put the bin before the date. So in fact, by default, on a Linux system, commands in /bin are normally on the path, or on the system path by default. So in theory, anything that's in /bin, you shouldn't need to prefix it with /bin. It should automatically be found. In this case, we put it there to be explicit, to point to the thing. But yes, it may well be that you can run it without, and it works fine. And I think that's certainly one of the things we've seen in the case here. Okay, so just moving back to look at the shell. So if we want to open an interactive shell, we can use the Singularity Shell command. So we've seen run and exec. So this is another command which we can use, which is very simple. We say Singularity Shell, and we pass it the name of the image. I'm just going to go a few lines up there to get rid of some of that output further up so that you can see it more clearly. So Singularity Shell, we tell it the image that we're using, and we run that. And what that's done is, again, we see the warning, and then we see a Singularity prompt. So we're now in a shell in a container that's based on this image. And if we look at what's there, it's kind of strange. I can see this hello world.sif, and I wonder where that's come from. And if I have a look at pwd, what I actually see is that I appear to be in the same location within this container that I was in on the host system. And that basically links to the point that was made before in the in the chat, which we're going to look at in a moment in the next episode. So for now, we just accept that we are in what looks like the same directory that was on the host system, but we are in the container, and we can see. So in fact, let's see if we do. Do we have an etc. issue? Yeah. So on many Linux distributions, there's a file /etc/issue which tells you what the version of that Linux distribution is. So here we're looking at the etc issue file in the container that's been generated from that image, and we can see that this is a fairly old version of Ubuntu 14.04. And if we go back to the main system, so if we were to go exit, so that just takes us out of the container, so that closes the shell, shuts down the container. If we look at that same file on the, in fact, do we not have it? Oh, sorry, we're on Archer, so we don't have it on there. If I show you on another platform, hang on, have I got something where I can show you it here? Let's do it on here. So let's just close that and just say it's an issue. So here we can see I'm on a different machine. It's Ubuntu 20.04, which is a much more recent version. So in fact, we've actually demonstrated, because we're on Archer, it's very unlikely that Archer is going to be running Ubuntu 14.04, I suspect. So it's got its own distribution, I would think, of that's much more recent than that. So what you can see there is that we were actually in a different environment to the main system where we were running. So if I go back into the shell, you can see that we're now in this sort of separate environment, and the kind of core system files in this environment are specific to that container and the image that it's based on. In fact, we can see there the raw.sh file that was being run by default. Have a look at it. Have a look what's inside it. So there's the actual command that was being run, the echo command to output the default output. But now we effectively we can run whatever we want within this container. Now, something to note here. Let me just go back to here. So we've opened this shell. We've opened this shell. There's a couple of questions here. So the commands that were shown here. So if I run who am I, so I can see there that the user is me, my user on the ARCHER2 system, and we already looked at the fact that there was this container file that appears to be the same thing that was on the host system. So what do you notice about the output of these commands within this Singularity container shell? And think particularly about what you notice about them within the context of what you might have seen previously within Docker. So, you know, when we looked at Docker yesterday, what would you have seen if you'd run who am I in a Docker container? Does anybody have any thoughts or questions on that? So there's actually a very interesting point there in the so yes, so somebody's pointed out that in Docker it was root. That's exactly right. So yes, that's already a difference. We can see in Docker we would have been root by default, whereas here we're our own user, and that's actually, that sort of points to one of the key differences here. So in this case, we're running Singularity in user space, and we have ended up in a container where we don't have any permissions beyond what we have on the host system, i.e. our user is the same in the container. Whereas in Docker, we would have had root permissions, and one of the examples of where that causes a major problem is that in theory you can bind mount, as we saw with Docker yesterday, a directory from the host system into your Docker container, and if you've got root privileges you can in theory change stuff there, which is obviously something that is not going to be what system administrators are very happy about, and obviously can potentially present a major security issue. So this kind of demonstrates that here we're in more of a kind of closed environment within our user space. We're not doing something where we have administrative permissions even within the container. The other thing that's been pointed out there, so I've just done a uname -a, so it was pointed out that this is actually the same inside and outside the container. So this is actually one of the main differences between when we talk about kind of virtualization and we talk about platforms or tools such as maybe VirtualBox, which are kind of full virtualization platforms, or containers. In this case, the containers are sharing the kernel with the host system. So what we're running is kind of a sort of sandboxed environment of files from our image within the main system, but the kernel ultimately is still, and the kind of core operating system behind the container environment is still the host system. So the kernel is still the same kernel that's running on the host system, and that's what the container is kind of interacting ultimately through the container layer with. Whereas if we were running, for example, a Linux virtual machine in VirtualBox, it's very different, because that a platform like VirtualBox, a virtualization software virtualization tool like that, is providing you with a kind of full virtualization layer, and you're actually running a kernel specific to the virtual machine that you're running in there. So I hope that makes some sense. If you're not familiar with the kind of virtualization layer, maybe it's a little bit confusing, but certainly that's the explanation for why you're seeing the same inside and outside the container, because actually the container is still running on the same kernel as the host system. Okay, so yeah, so the points that are being made here really are the fact that particularly the yes, we saw that we were our own user in the Singularity shell. We are not the root user, but of course, if we did have root on the system and we'd started the container as root, then we would be root in the container. So basically, whatever user we start the container as on the host system is what we end up as inside the container. And so yes, this does differ from what we might see within a Docker container. As was pointed out, you would expect to see root in a Docker container regardless of the user that you used to start it. And the other thing that we noted there was that we can see what seems to be the files in our home directory on the host system, and we will come on to look at that very, very shortly. Okay, so are there any questions at this stage about you just running general commands and running a shell and so on beyond anything we've already looked at? Okay, so there's a question there about whether this means that there could be incompatibility issues between the host kernel and the container. Potentially, I think the answer is yes, but I think in most cases it shouldn't be a problem with Linux distributions. I mean, this is one of the reasons why we're kind of restricted into a Linux environment here. So in general, I guess that this is not a major problem for standard kind of use. But of course, if you get into an environment where you're using specific modules or things like that, then yes, potentially there could be a problem.
You typically only see this if you're accessing some stuff via some sort of low level, like the hardware. So say you try to use GPUs aren't the right example here, but you know what I mean. If your container doesn't, or your host doesn't have the GPU drivers, the correct GPU drivers, then you can run into problems. But similarly, on there may be kernel level modules, say you're trying to access SCSI devices and SCSI the kernel's been taken out. For some reason, there could potentially be problems there, but for most cases, containers are based around software use rather than hardware resource use, except for things like GPUs, which is dealt with differently. So it tends not to be a problem.
Yeah. Okay. Thanks for that, Andy. Yes, that's a very good point there. Okay. Right. So I think we'll move on to look at the files in Singularity containers, and this actually will cover some of the points that were made earlier. So we've seen how to start containers. We've seen how to look at how to start a shell in a container, how to run different commands within a container. How do we actually make data available in a container? How do we access data? And what can we do then once we've got access to that data? How do we work with it, and so on? So we've already seen that the way user accounts and permissions are handled in Singularity is different to Docker. We saw in the previous example that we have our own kind of user. We are our own user inside a container, and so we only have the permissions of our user inside the container. So if we look at, we saw actually, I mean, this is basically showing you what we did in the previous section. So if we run a Singularity shell with our hello world image, we do a who am I, we see that we are our own user. So the question here might be, how are we our own user? So we looked at the fact that was the case in the previous option. But if you know anything about Linux system administration, particularly, then you might ask at the question, well, I downloaded this standard image. It's come from another user. It was created a long time before I created my account on ARCHER2 with whatever username I created. How does the container that I've created from this image have any idea who I am inside the container? So, if we look at running a Docker container, we end up as root, and the Docker container really doesn't know anything about what our user is in the outside world, so outside of that Docker container. It's a completely separate kind of environment, so we can create users in the Docker container if we want to, but we are not by default the user that's on the host system in the Docker container. There are some arguments that's not entirely true, so there's some different mappings that are done with Docker desktop between users on the host and the in the host system in the containers, but we won't worry too much about that for now. In principle, it's a kind of separate environment. So here we've got an environment where actually we've started this container and it seems to know who we are inside the container, even though it's kind of a separate sort of sandboxed environment from the host system. So if you do have Linux sysadmin knowledge at all, if you've ever explored this, you might know that there are sort of two key files in a Linux system. There's etc password and etc group. And those are the files that are used to store details of the users and groups on a system. So within a Linux system, you have the concept of a user, your user, and a group. So we can quickly just look at this. So let me just exit out of that container shell. So if I look at some files, so I'll just do a directory. When I look at the long directory listing with ls-l, I see files have ownership, and it tells me that the file is owned by this user and this group. So that's my user, and then I'm a member of this group. And what that means is that you can set up permissions to the file that are specific to the user. So I can say I'm allowed to read, write, and execute this file. But you can also set up a separate set of permissions that's specific to the group. So I might want to say that people in this group, so that's probably the rest of you on the course, likely to all be in this group, can read this file, but you can't write or delete it or whatever. So this gives you flexibility to set up file permissions for users and groups, and that's why this kind of concept of users and groups exists. We won't discuss that in great detail, but that's basically just to give you some background in case that's something you're not familiar with. So anyway, there are these two files on a system that determine the list of users and the list of groups, and in order for the shell within the container to know who I am, so when I go into this shell in my Singularity container, it needs to have some information in those files. So this gives us the question, how does that information get into those files? Because clearly it has to, those files have to have been changed. But all I've done is said Singularity Shell or Singularity Run or whatever I've done, this image. So somewhere along the line, something has happened that means that it knows who I am within the container. And why is it doing that? Well, it's doing that so that it can ensure that I have the same permissions inside that container that I have on the host system, and that I cannot make any changes to or delete any data that I shouldn't be able to delete on the host system. So basically it ensures that I'm kind of locked down to that user. So the way that this is happening is that when Singularity runs, when it runs a container from an image, it binds some directories from the host system where you're running the Singularity command into the container that you're starting. Now, we saw yesterday in Docker that we could do that with the -v switch. There's also -mount or -mount. I don't think we looked at that yesterday, but they're both sort of similar switches. But with -v, we saw that we could mount. I think we did several cases where we did -v and then pwd for the current working directory, and we mounted that to some point in the Docker container. But we had to explicitly do that if we wanted to mount the directory on the host system into the Docker container. In the case of Singularity, it's actually by default binding some directories from the host system where you're running the command into that container. And it's not copying the files, so just to be clear, it's basically just creating a view of those files in the container. So it's just making an existing directory on that host system visible in the container. There's no actual copying of files happening. So what you see when you're in the container should be the same as what's outside, and in fact, if you make changes in the container, if you have the permissions to do so, they should then persist, they should be visible in that directory when you exit the container. So if you write files to the bound directory in the container, then when you shut down, those will be visible on the host system in whatever the location is that was bound into the container. So there is a default configuration of which files and directories are bound into the container. So this is where things are a little bit different to Docker. So when you install Singularity as a system administrator, you have some control over kind of what's actually made visible and how that's managed. And so there's a kind of default that seems to be most common on many systems, but equally system administrators do have rights to change that, and they can turn certain things on and off depending on what sort of control they think they want to to have on the host system and what concerns they have regarding security and so on. So things may differ on different systems, but there are some sort of fairly common approaches that you will find, things that are fairly commonly available on a Singularity system. So what we're providing here is an overview, but you may find that if you have a system on your local HPC infrastructure that has Singularity on it, things may be different. But one directory that is likely to be accessible and is frequently accessible is your home directory. So exactly as we saw in the example in the terminal here, I'm currently in, so in fact, let me drop back to my, so if I just do CD with nothing else, that puts me back to my home directory. So I'm currently here in my home directory on ARCHER2. And if I run, in fact, let me just do an ls to show you. So there's a few files in there. There's a directory, ls-l, you can see that D tells me it's a directory there. So there's a directory benchmarks, there's this hello world.sif file, and then there's a test directory which also had hello world.sif in it. I think that was the one I was just in doing the demonstration. So let's run a Singularity shell here for hello world.sif. Okay, so now if I do pwd, I am in fact in the same location that I was in on the host system. And if I do an ls, I can see the same set of files, same directory, whatever. And so let's say that I choose to create a file in there. So let's just do, so I'm just going to use cat to generate a file. So let's call it test.txt. So we just create some test files. So I'll just say this is text file. Okay, right. So now if I do an ls-l, I can see that I've got a file called test.txt. It's created with the same permissions that I expect on the host system, because that's my permissions within the container as well. And if I now exit from the container, I do an ls, the file is there, I can see it here. That's the file I created in the container, but I'm now back on the host system. So we can see that by default, the location was available within the container. I've been able to make a file in that location, and I've been able to view that when I've come out, so it's persisted on the host system. Okay, so if we look at how those kind of mappings work and how the users are set up, this is a sort of an illustration to try and give you an example of what's actually happening here. So here we have on the left-hand side the host system, and we have some set of directories on the host system. Again, if you're familiar with Linux, you'll have some sort of standard directories that you see on standard directory structure on most Linux distributions. So you'll have in your root directory, you like to have a bin and etc. and home, user, sbin, and many other sort of common standard directories. Then we have the Singularity container. The image that we've based that container on, which we saw before when we looked at the etc. issue file, was an Ubuntu distribution. So again, it's a Linux distribution. It's going to also have this same kind of structure of directories, or similar structure of directories. So what's actually happening is that Singularity is, in this case, taking the details from the group and password files on the host system, so on ARCHER2, and it's taking the relevant details for my user. And when it starts the container, so it kind of opens up the image and starts the container, it's adding to the files in the container the relevant details for my password and group setting. So in fact, I can look at that if I go and create a shell again, and so I see that I'm my user, and if I look at etc. password as an example, so there's a whole bunch of stuff here which is actually just the standard stuff in the Ubuntu distribution. So that's not anything to do with ARCHER2 at all. That's what was already there in the image. And then what's happened is that my username has been added to the bottom of that with the relevant user ID, which is this number here, and then the group ID. And those are what kind of determine the ownership of the files. So that ensures that when I create files, that they are the same permissions as out on the host system. When I go back to the host system, they're accessible. We can see the same with group as well. So again, this is a really standard sort of Linux setup that you'd get. So the file on ARCHER2 will be different to this, but this is a kind of standard Linux group file, and then it's added to the bottom of it some content that's come from ARCHER2 that shows which groups my user is a member of. So that's basically what's happening there, and that's what's illustrated here. And then it's also actually doing a bind mount of some directories. In this case, it's done a bind mount of my home directory into the home directory on the the Singularity container, and that's why I can see the content from my home directory there. So hopefully that makes sense. There's a few questions here. I don't know whether we need time to go through them, or whether I'll just have a read through and just see whether it might be worth just sort of going through them with you. So question one is asking, what do you notice about the ownership of files in the container started from the hello world image? So we've actually talked about that already in some detail. If we actually look at the root directory, because that's something we didn't do. So if we start our shell again, we look at /, let me do an ls-l so you can see. So what you notice here, which is actually really interesting, is that a lot of the files are owned by root. And what that means is that even though I'm in a container that I started, I can't edit the files that are owned by root. So that's ensuring that so these are not files on ARCHER2, these are files in the container that I've just started. But I still can't alter the content of those files because I am not the root user. So I still have some restrictions in the container. But I can edit stuff that's within the directories or the files that I own, which is some of these files like home, which has been generated and mapped from the host system. So that's the sort of question one. So if we did try editing a file, so let's try, so this is a good example. So here's the sort of raw.sh file. It's a really simple shell script. We looked at it before. Slash in front. Okay, very simple shell script. I'm going to try and edit it, and I'm going to use VI. I think VI is here. Yes, it is in this kernel. So VI. Okay, and what I see straight away is that actually the file is read-only, which means that, so I had read permission because that's how I could show what was in it, and I've actually been able to open the editor, but I can't actually change anything because it's not owned by me. So if I try to put something in here, it says actually at the bottom, warning, changing a read-only file, and if I tried to save that, it tells me read-only option is set, so I can't actually do it. I don't know if I can override it, but I don't think so. No. So if I try to override it, as it said, it tells me it can't open the file for writing because I don't have the permissions. So, so I'm going to exit out. So we can see there that we still have restrictions within the container based on the file ownership. Okay, so the other thing was looking in your home directory within the shell, trying to create a simple text file. We've just done this and we've looked at it, and we saw that we could do that within our home directory. And we also saw that when we shut down the container, that we were able to see the file in the home directory on the host system. So it persisted on the host system. Okay, so I hope that that makes sense. Do let me know if you've got any questions on any of that. We've got any questions in the chat here? I think looks like that's all. You can see that there's lots of discussion going on there, but I think everything looks okay. So okay, so I will move on to the next section. So we saw that there's a bunch of stuff that's bound by default, but what if you actually want to add some other directories? So we saw in Docker that we could use the -v switch to bind mount directories. Is there an equivalent in Singularity? Yes, there is. So let's say, for example, that you've got a directory where you've got some files on the cluster. You're working on a cluster, you've got a bunch of data sitting somewhere. It's not in your home directory, it's in some big shared folder that you've got with some shared space for large-scale data. And you want to make that available within your Singularity container. So to do that, we have the -b option. So that's what will allow us to do a bind mount. So here's an example of using a particular directory. Let's have a look on the ARCHER2 platform directly. So if I so exit out of that container, so let's have a look in work. So I'm guessing that I've got a, so here's a work folder. So we've got a work folder for, do I have my own folder? Let's have a look what's there. So in fact, it's in there. So I think it's in there. Right, so there's my work folder. Do I have anything in there? Yes, I've got a few files. I've got some output scripts and whatever. So let's say I want to make that available inside my Singularity container. So we can again run our shell, Singularity shell, with the hello world.sif image, but we're going to use this -b switch here, and we're going to use that to tell it to mount the work directory that we just looked at. So let's add that in. I think, did I copy? Let's just copy and paste it. I have to type it out again. Okay, so start a shell, bind work following directory into the container, and use this image to start the container. Note that we haven't said where to bind it to. So in Docker, we would have put -v. We would have said that the host, the directory on the host machine, and then we would have said : and where to bind it to. In this case, we're not actually doing that. We're going to go into the container, and we'll find that it's actually available at the same location. So if I look now at work, I can see that that directory actually exists now in my container. I can assure you it wasn't there before. It's basically made that available, and it's showing us that the files are there. And if we look at we do a long listing so we can see the ownership, we can see that the files are owned by me. And what that means is I should be able to create files in there in the same way that I was able to create them in my home directory. So let's do exactly the same as we did there. So let's create a file Note, I'm just using the cat command here and then the redirect. So this is just a very simple way to create files without having to go into an editor. So what I'm actually doing is just saying use the cat command and then redirect the content that is being echoed effectively into this file that I specify. So, okay, and then I type I want to go into the file. Okay, and then in fact, to close that, you have to use Control D. So I'm using Control D to close the file and write it. And what that basically means is that I've now written that file at that location. If I do an ls of that, in fact, let's just do an ls of the directory. And you'll see that the file is there. And let's just show you the contents. You can see it's saved. And if I exit now out of the container, and I tried to do the same thing, the file is still there on the host system. So we were looking at the directory we bound into the container was kind of a view of the same directory on the host system, and the files that we change there persist. So that's a great example of how if you're running, say, for example, you've got a model or some sort of algorithm that you're running in a Singularity container, you can mount a directory with some data that's on the host system, so you don't need to copy all the data into the container, and then you can run the process that you're running on that data in the location on the host system, and then when the container finishes and exits, the output will be there on the host system for you. So it's quite a nice way to actually be able to work with that. And as we saw yesterday, you can do that with Docker, but obviously in this case, if we're working on an HPC infrastructure, we wouldn't expect to find Docker anyway. But it's a similar kind of thing to what you could do with Docker, but it's just more suited to this kind of environment. So that's demonstrated the use of mounting by mounting the directories. You can see here that you can do what we did with Docker yesterday. So you can use the : and give it a different location. That's something which you may want to use if you want the files to appear in a very specific place. So I can show you that if we just go back to the container and we do run. So there's our Singularity Shell -b. So let's say rather than mounting it at that same location, we want it to mount at /myDataDir. Doesn't really matter what we call it, we'll just do that as a test. So we start the container and we do an ls -l, and there you can see that there is now a directory called myDataDir. It's owned by me in the root directory. If I go into the root directory myDataDir, we see the content of that directory that was on the host system. We see that file that we created just now, and can work with that in the same way. It just happens to be mounted at a different location. Okay, do we have any questions about that part of the material? So that basically concludes the material on the files. If you've got any questions on that, please do feel free to ask them. I don't know if we've got anything in the chat. I don't think there's anything there at the moment. No? Okay. So what we're going to do now is, just to finish off before lunch, is look at this idea of using Docker images with Singularity. So we've seen how to use Singularity images, we've seen how to get them from Singularity Hub. With Singularity Hub is growing, there's quite a lot of material on there, but the Docker community is much, much larger at the moment. There is a huge amount of material out there in the Docker space. There's a huge amount of container images that are available, and the fact that you can kind of interoperate between with using Docker images with Singularity gives you a huge amount of flexibility. So we're going to look briefly at how you actually work with Docker images with Singularity. So we saw before that when you run a Singularity image, when you pull a Singularity image, it's basically just one file. It's a CIF file. And we also talked about the fact that Docker uses a different format with this kind of layered approach. So when Singularity is running an image that it's got from Docker, it's not actually running the Docker image as such. It's running still a CIF file, a Singularity image file. So it has to create that from the Docker image. So what's actually happening here, and what we're going to see in a minute, is that when we obtain an image from Docker Hub, Singularity goes through a kind of conversion process where it changes it into a Singularity image file, which it can then run in the same way as it's running any other image, like the Hello World image that we saw. So moving on from that sort of simple Hello World example that we saw, let's have a look at one of the official Docker Python images. So I think we looked yesterday at these. So if I open this and just show you, so this is Docker Hub, this is the official Python image in Docker Hub. You can see that there's a huge number of versions and tags there. These are all the different versions of the Python image and the different tags that are available. We are going to use a kind of recent version of Python 3.9.6, and we're going to use the slim version of the image. So that's a kind of cut down image that's got some less content and packages and whatever in there. And we're using the Buster version, which is a Debian Linux distribution. So Debian is one of the commonly used Linux distributions, and Buster is one of the releases of that. So that's version 10 of Debian Linux. And that's the name of the image from Docker Hub that we're going to be using. So what we can actually do, before we did Singularity Pull. So I'm going to take that from there, and I'll just switch back to my terminal. So previously, let's just check where we are here. Let's go back into the test directory. So that's where we had our hello world.cif. So previously we were using something like shub / whatever to determine that we wanted to get our image from Singularity Hub and what the name of the image was. Here we're going to use a slightly different format. We're using Docker // so that tells Singularity that it's coming from Docker Hub. So what we say is Singularity Pull. Give it the CIF file name that we want this to be stored at. So in fact, maybe it's more sensible to name, let's leave it at that because it's shorter. And we say where to get the image from. So we run that. The Singularity has now gone off to Docker Hub, and we can see something slightly different is happening to what we saw before. So previously we just saw this very quick line go across for our 60 megabytes image being pulled down. What's actually happening here is that it's gone off to Docker Hub. It's getting the list of layers that make up that container image, and it's then actually getting these what it calls blobs, which are these sort of layers of the image, and it's converting them into a Singularity CIF file. We're seeing a bunch of warnings there. They look like file system warnings to do with file attributes. I wouldn't be too concerned about that at the moment, but there's clearly that's something because of the file system we're running locally on the system here. So it shouldn't be a problem. So there's different types of file systems that are running on different systems, and it's trying to do something with particular file attributes which are not supported on this file system, which is why it's giving us warnings. Shouldn't be an issue. So if we now have a look, we've got our Python image. We can see that in fact it's very small. It's actually smaller by it seems than the Hello World image, which is so it's a very cut down image. And now that we've got that on the system, we can actually go ahead and run it. So this I'll leave you to see whether you can do that. So we'll give you a couple of minutes. I know we're just about to break for lunch, but I'll just give you a couple of minutes to see whether you are able to run that yourself and what happens. So have a go at that and see how you get on. we're just about coming to the end, so we'll. So while you're doing that, I will actually. It should be pretty straightforward. I'll do the same on here. So I guess some of you will already have done that. I will try and run the same here. Singularity runs here. Okay, so I'm guessing many of you might have already done this. So what I've done here is I've done Singularity Run, and I've given it the name of the image, exactly as we did with the Hello World image. But we see something a bit different here. Rather than just printing something out and exiting, what we've actually done is we've gone straight into a Python interactive shell. So I'm now effectively in a Python interpreter. I can type Python commands, Python code, and I can see that there's things are there. I can run things, whatever. If I want to get out, I can type exit, and it drops me out and exits from the container as well. So, where we can see that we very quickly managed to pull a Python image, we've got a Python interpreter running straight away. If we wanted to create a shell in that image, we could also do that. So we run Singularity Shell. Now we can actually see the file system in the image. There's our mounted home directory. If we look at the user bin Python, is it? No? Let's have a look whether we can say which one. A user local bin. Okay, so so what we can actually see is that in user local bin, we've got Python 3.9, pip, all various other things, and we can actually just run a Python interpreter straight away in the shell if we want to. And of course, what happens differently here, and again, just to prove that we're in a Python interpreter, when we exit, we don't exit the entire container, we just exit from the interpreter back to the Singularity shell. So we're just still in the container. And then we can exit out back to the host system once we've done whatever we want to do. Okay, so hopefully you were able to get that to work. So there's the example of what we did. Hopefully that was successful on your system. And in fact, hopefully if you're running on ARCHER2, you saw exactly the same as I did. We also looked at how to open a shell in the container. So if we just open that, we can see there that's exactly what we did. We didn't run the various commands, but you can certainly try those, and hopefully you'll see the same thing. So here we can see that it's Debian Linux. That's what we looked at when we looked at the fact there was a Buster image. That's Debian Linux 10. But that's effectively the process that we did. And there is another way you can do this. So running Singularity Shell is fine. It runs a shell with whatever the default shell is. But you can also use Singularity Exec. We saw Singularity Exec before, so it's exactly the same. Running Singularity Shell is effectively exactly the same as running Singularity Exec and then telling it the shell to run, in this case bin bash. But if you wanted to run a different shell to the one that was running by default, say you have multiple shells installed, you could use Singularity Exec and give it a different shell to run. Okay, so that is the end of part one of the material. So we got a question, interesting question in the chat there about whether there can be a single curator of local CIFs for a group, and other users can then use Singularity by referring to that CIF. And I think yes, definitely. That's I mean, there's no reason at all why you couldn't produce your own kind of local repository of images. You could just put the CIF files in a shared directory somewhere, and yeah, as you've seen the response there, that's exactly what is being done on ARCHER2. There's a directory with that, and of course it's a great way to save storage if you have a sort of shared location with all those CIF files, and people can just sort of run them from there, or take a copy and run them if they want to.